Before we continue with the rest of this laboratory exercise, I also would like to take a quick look at the shader programs, just to visualize what our shaders are doing. So this is our vertex shader right here, and this is our fragment shader. So I'll just move these two separate tabs. Currently, each vertex is described by its own position and set of other attributes like colors, and so individual vertices are stored as an array of numbers. And this array becomes an input for each vertex shader that executes its GL position. Its position is transformed by multiplying by model matrix, the view matrix, and the perspective matrix, and this is our output. Our fragment shader is expecting an input parameter, which is the color, and of course the colors are configured as a separate array right here, and we also use another input variable named color in our vertex shader. And then what we do here, we also declare an output variable which is linked to the input of this color in the fragment shader. And all we do is just pass this color over to the output, which becomes input in the fragment shader. The fragment shader also doesn't do much with this color. It just declares the output, which goes to the next stage in OpenGL graphics pipeline, and it just passes it to the output vector. Without an index, these array elements are processed sequentially, one after another, to describe our geometry, form the triangles, and eventually making them visible. So with new index facility, the array of indices is also loaded into GPU memory, but this time the index controls which vertex attribute is processed first and which one is processed next and which one is processed next, and so forth. Basically now the index array controls the order in which we get our vertices, transform them, and then forming triangles, and eventually generate fragments to make it all visible. As you can see, there is nothing that needs to be changed with respect to using indices of vertex attributes. All there is to it is to load the indices and then either call draw arrays to get direct access to the arrays of individual vertex attributes, or use draw elements, which uses the index array to specify the new order of the vertices that correspond to our triangles. And in cases when there are thousands of triangles, indices can save a lot of memory that would be needed without them, and require less processing power from the GPU hardware. So as far as our vertex code is concerned, there is nothing special that we have to do in our shaders to handle the indices.